What comes to mind when you think of the ocean?
Fish,
Coral,
seashells,
seaweed,
jaws,
Finding Nemo,
a huge massive garbage twice the size of Texas.
oh, you mean the Great Pacific Garbage Patch?
The Great Pacific Garbage Patch is a gigantic patch full of litter that ends up in large bodies of water. All this litter is spinning around in a vortex, so the garbage remains in this patch as it breaks down. These vortexes are able to hold all the trash because of the patterns of wind and the rotation of the planet. These are often called gyres. One thing most people don't know is that there are also garbage patches located in the Great Lakes, including Lake Michigan. The garbage patch in Lake Erie is actually denser than the one in the Atlantic Ocean. According to recent findings, there is about 24% more microplastics in Lake Erie than there is in the Atlantic. You may be thinking, doesn't plastic keep its shape forever? However, larger pieces of plastic break down over time by exposure due to UV rays that the sun produces.
These are called microplastics. Microplastics are tiny forms of plastic that come from objects like water bottles. They degrade over time and become the tiny pieces you see now. Microplastics can come in any shape and in any color. Also, when mixed with water, they can create a poisonous fluid that is eaten by animals such as fish,
which later in the food chain is eaten by us.
For our science experiment, we decided to take sand from two different beaches. One is Bradford Beach and the other one is Doctor's Park. We used these containers that should hold up to 2 cups of sand.
We took sand from two very different beaches. One is Bradford Beach, a place where a lot of people visit. More people means more trash. But with it being an attraction, this trash is likely cleaned up after. The second place being Doctor's Park. Few people visit compared to Bradford Beach, meaning less of a cleanup crew. So we suspect that there will be more microplastic on Doctor's Park than Bradford Beach. So we went out onto the beach and scooped up 2 cups of sand. We always made sure to take the dry sand 11 feet from the shoreline. We used an 8-inch diameter circle to keep the depth consistent. We used the spoon to scrape up the sand inside the circle until we had 2 cups. Then we brought the sand samples back with us to analyze our data. For the extraction of the microplastics, we took one of our sand samples and poured it into the glass jar. Then we poured water into the jar and used an aluminum rod to stir. If there were any microplastics in the sand, it would float to the top of the water. We tried different methods of removing the floating microplastics, using a wooden spoon, a skimmer, and even hands with gloves on. Then we took the microplastics out and measured its weight on the electronic scale. We repeated this for each of our samples and recorded the measurements. For our data, we found that Doctor's Park had more microplastics compared to Bradford Beach, as shown in the results. In other words, the more remote beach with lake debris had more microplastics than the more popular accessible beach, which had almost no lake debris.
Seeing what really washes up on shore shows the impact of plastic pollution in our own backyard. We hear the 3 R's all the time. We're told to reduce, reuse, and recycle. But that doesn't always translate to people taking action. We hope our experiment and video has shown you that there's more to plastic pollution that meets the eye. Eventually, over time, throwing away plastic has a consequence of more plastic adding up in our lakes and oceans, as well as our food chain and even inside our own bodies.
Plastic floats when it's in water. So, we poured the sand in this jar first, then we poured the water in. Bruh! Get out of the picture, Sam! Now!
Look at that chicken. As well as our food chain.
Crap! A huge, massive garbage twice the size of Texas?
What you talking about? You mean the specific garbage patch? Specific garbage patch? What the?